Hello learners, in this video we'll discuss the projection of solids onto the vertical as well as the horizontal plane. Um, this is from the second module of the Kerala Technological University's Engineering Graphics syllabus. So let's begin. So in this model I have created a bunch of solids that you can see here. So the first four are prisms, then there is a cylinder here, then there are two pyramids, and there is a cone. So basically they have enumerated a list of solids that you have to learn to draw the projection of, and they have listed prisms, they have listed pyramids, they have listed cylinders and cones. So basically the first solid that we have here is the prism, that is the triangular prism. As you can see, it is a triangle which has been pulled up so as to give it a three-dimensional shape. Then there is a cuboid, which is actually basically a square prism. And then there is the pentagonal prism, because as you can see, the one of the face is a pentagon. Then there is the hexagonal prism, because the face is a hexagon. Then I have created a cylinder here. There is a pyramid. Because one of the faces is actually a square, we call it as a square pyramid. This is actually the view from the top. Here again we have a pentagon, and we have a pentagonal pyramid because we have these vertexes. And finally have created a cone. So these are the shapes or solids that we have to learn to draw the projections of. So let's see, this video will help you to visualize how a solid's projection is made on the vertical as well as the horizontal plane. So the projection made on the vertical plane is the front view, and the projection made on the horizontal plane is the top view. So let's see how these projections of the solids will look like. So for in the first case, that is the triangular prism. So I'm going to now draw the projections. Okay, as you can see, when I'm drawing the projections, what I'm getting is a rectangle, because when you're looking from the front, all you can see is a rectangle. Obviously the dimensions will be of a reduced or apparent length. It will not be of a true length, because this edge is actually inclined. If I'm looking at for the top view, I'm getting a proper triangle, because from the top view we have a triangle. And moving on to the next model, that is a square prism. So I'm going to get the projections here. Again, that is going to be a square. From the top also it is going to be a square. So sorry, this one is actually a rectangle, because the height is actually more than the width of this particular solid. And this one, the horizontal, the pentagonal prism. So when you are viewing from the front, you have an extra edge on the front. That edge is visible, so when you are projecting it, you will also draw that edge. Okay, I hope it makes sense. And then for the top view, it will be a proper pentagon. And moving on to the hexagonal prism. So I'm going to get the projections on the side. Yes, so these two edges are also visible, and they have to be incorporated on the front view of the solid. Regarding the top view, because it is a hexagonal prism, you get a hexagon. Now the next one is the cylinder, the circular cylinder. So as you will already know, if we are viewing from the front, all we are seeing is a rectangle. Okay, so in the projection also you will be getting a rectangle, and from the top what you have is a circle. Moving on to the square pyramid. Projecting it to the face, the vertical plane, we get the front view, that is a triangle, because As you can see here, this is a triangle. From the top, it is a square, and you get this cross because you these edges, these corners and edges, they are all visible, and this vertex also, it is visible. Therefore, you get that cross also on the top view. Moving on to the pentagonal pyramid, it is a similar view in the front view. Okay, you have to draw those, the faces also. The face or the corner edges are also visible. Alright, now from the top view, again another pentagon, but there will be lines coming from all over the corners to the central point, so as to represent the projections of these edges. Alright, and now finally to the cone, circular cone, I will again get a triangle. If you can see this from here, what you are seeing from the front view, it is actually a triangle. Okay, and there is no prize for guessing what you will get on the top view. Obviously it will be a circle. So this was how we get the projections of these solids. All these solids are kept in the first quadrant, that is at a height from the horizontal plane and at a distance in front of the vertical plane. So let me just remove these solids or place it, move it upwards. Okay, so now in order to get the actual orthographic projection with the XY line, all you have to do is that we have already seen this. We have to get this horizontal plane and rotate it at a clockwise direction about the XY line, or the intersection between the horizontal plane as well as the vertical plane. Okay, in order to get the orthographic projection, you have to rotate the horizontal plane in the clockwise direction by an angle of 90 degree. Alright, so if you are seeing from the front, you get the orthographic projections. What you see above the XY line, that is the, if this is the XY line, what we are seeing above is the front view, and what is below the XY line is actually the top view. Here at the top in the red color, you can see the corresponding solids. If I'm changing the view, you would be able to see this. These are the solids, and this is the orthographic projection of the above solids. So I hope this video helps you to visualize these solids being projected onto the vertical as well as the horizontal plane. Thank you for watching the video.